Let's think for a second first about 4 times 6 and how this can be thought about in terms of visualizing for groups of 6. Now, conventionally, the first factor is the number of rows, and then the second factor is the number of columns. And for an area model, the 4 would be the vertical distance. So this is a convention. This is not a right or a wrong, not about marking kids wrong if they do it the other way. I don't believe in that at all. But so if I wanted to make a 4 by 6 rectangle, I'm here in Branding Camp. It's my favorite virtual manipulatives. It does cost a little bit of money, but it's incredibly reasonable. And it's amazing because you get 16 different math tools plus their unlimited supply, and they have no germs. So I've also been doing some work with them to do trainings for districts that purchase it for the school of the district. But all right, so I've put on here, I'm in a work mat in Branding Camp of whole numbers, so you can see the numbers. I know that if you're not familiar with the Cuisenaire rods, that might be a little confusing. But the benefit of them is that the amounts exist as a group, so rather than a collection of ones. I've seen too many older students draw arrays with like a 6 by 9 array with X's. They don't do it in columns neatly, and then they end up counting them one by one, and they're off by one. So these help move our students forward in the development of mathematical reasoning, the Pam Harris graphic of counting phase of reasoning into additive, into multiplicative. So if you think about this, I've got this 4 times 6. I have 4 groups of 6, right? The vertical distance is 4. I know that the horizontal distance is 6. And this total amount is the amount of, I can think of it as 4 6s. I could think of it as 6 4s, but however I get there, I'm thinking it is a total of 24, right? Well, division is the inverse. What that means is that we're going to start with the 24. We're going to divide it by 4 to see what this missing factor is, right? But think about the division sign. Doop. So within here, we have the total amount, which is the area. Every multiplication problem will result in a rectangle. So you can visualize that whenever you're multiplying anything, it will always result in a rectangle because you get equal sized groups. So you can think, okay, I've got this total amount. I'm dividing it by the divisor, which is going to be the horizontal distance. And I could think about when I figure out this horizontal one, did I say horizontal? This is vertical. So the vertical distance here with the 4, the horizontal is going to be whatever the quotient is, right? So we have our dividend, our divisor, and then the quotient. So when I think about that, then if I were to think about 24, let me just write that. So 24, if I were to do it in another way, 24 divided by 4, what is that equal to? Well, what I would do is I would grab the amount that is that total amount. So I would grab 20 and I would grab a 4. And then I'm going to say to myself, well, I'm dividing it by 4. So now there are 2 meanings of division. There's quotative and there's partitive. So partitive means I'm doing a fair share. I would take these 24 things and share it equally among 4 people, or the quotative, the measurement, is that we have, that's the size of the groups. I've got sizes of 4s. So what I'm going to do is I'm going to be lining up my 4s. This is the size of our group. I'm trying to find out how many 4s are in 24. So I'm just going to keep going with the 4s. And I came out exactly equal. There's no leftover remainder. And it turns out that I was able to make, actually I'm going to rotate them. So I can make my area. So I know that there were 6 4s that made up 24. And so as I rotate these, I can take that amount. I know the area of these 6 4 rods is 24 because it matched up linearly to the distance that I already had out there. And I can now rearrange these into an area model. But I can see that I know the total amount inside here is 24 because I was able to line them up and it matches this distance. My divisor, I'm dividing by a 4. So I'm dividing here by that 4. What is this distance? Well, it's distance of 6, which means that 24 divided by 4 is 6. If I had been dividing instead by 6, then I would have used 6 rods, right? So I could have then taken the 6 rods, put them beneath it, and seen how many of the 6s. Turns out to be 4. Now, so that's one way of thinking. So the thinking behind the area model is when I know the divisor, do I know any groups that can help me get to my total? So let me just clear this for a second and let's do a little harder one. Let's do one that has multi-digits. Okay, so in this example, a little more difficult. We've got a 2-digit by 1-digit. So I've got a 52 divided by a 4. So my thought is I want to make a rectangle. I'm going to have my vertical distance here be the 4. So I'm dividing by a 4. And I know that the area inside here has to be 52, which means all of these manipulatives here had to be rearranged into a rectangle. So I know that the whole value of it would be 52. So the question is going to be, well, what's my distance? That's going to be my quotient. So the thinking here, I actually find it getting easier as the numbers get larger because I can use multiples of 10s. So what I would say to myself is, well, 4 times something has to give me something that's going to go down below here, right? So do I have enough for a 4 by 10? Do I have enough for 4 by 10? Well, how much is 4 10s? It's 40. And I do have that amount. So I can then build in this open array here. I can think, well, I at least know that 4 by 10, that makes, I've got 40 so far of my dividend. And I know that distance is 10. So I already have at least an answer of a 10. What I have here is 12, right? So if I have my total remainder of this left, so I would have, physically removed the 40, but now I've got 12 left. I could even do that abstractly, right, with the with equations. But I've got 12. Well, I'm dividing by a 4. So how many 4s can fit into the 12? I'm thinking that quotative division. I know the size of the group. Well, it turns out there are 3. So what I can do is I can orient them here. And so the value of these 3 4s is 12 because I know it lined it up down below to this 12. So I did an equal fair trade there. And so then what's my total distance? Well, I know I have 3 more 4s. So that total distance is a 13, which means that 52 divided by 4 must be 13. So the thinking is going to be the same now. We're going to think about, do I have enough to make 10 groups? If I do, can I do 20 groups? Can I do 30 groups? Right? We're going back to those multiplying by multiples of 10s to be able to help get a big chunk out of there. And then we're going to deal with whatever we have left over. And then we're trying to find out what that distance is across the top. And that's going to be our quotient. So I do want to show you within a different app. This is, as we're going to set larger numbers now, this is the base 10 blocks. What I typically do actually is in person, in physical manipulatives, I use the 10s and the 100s from the base 10 system, and I use Cuisenaire rods for the ones place. I'm always mindful of moving the kids past the counting phase of reasoning, and those ones cubes, they're just counting them, even upper elementary grades. So if I have 156 divided by 12, my thinking is going to be the same. My thinking has to be, I need to have 156 in the area. So I'm going to bring down the 100. I'm going to bring down 50, and I'm going to bring down 6. And you can see here that it is labeled because of this eyeball, but I can see the total amount. So I have that 156. I need to rearrange this quantity of blocks into a rectangle, which is going to measure 12 in this vertical distance. So I say to myself, well, do I have enough to build a 12 by 10 rectangle? Well, how much would that be? 12 times 10 is 120. Do I have that amount? I sure do. So I'm going to place this right over here. And I'm going to just change the orientation of this. And I'm going to bring down this one as well. And so you can see here that I have made a rectangle that comes down 12 and goes across 10. And the area inside is 120, which means I have 36 left to deal with. Well, now I can think about maybe them as 12s. Well, do I have enough to make one more 12? That would be 12. Can I make 2 more 12s? So that would be 24, and I've got enough for that. I have enough for a third one, and I do, right? So I can be taking these blocks. Now, there may be some examples of numbers where you're having to break them apart, right? Take the grouping and break them apart, and then be able to reorient them. But again, the goal is always to make a rectangle. So here I go for my last 12. I have now made a rectangle that measures 12. The area inside is 156. My divisor with vertical distance is 12. What is this horizontal distance? Now, these are on the outside to kind of help label things here. So you wouldn't necessarily have to do that, but it has a total distance of 13. Which means, of course, 13 times 12 is 156. But so if the students have had practice and experiences building the area model with multiplication, the division is just the inverse of it. It's taking this total amount, thinking about the divisor, and rearranging this amount in a way that allows us to see what the horizontal distances. And then we know that that is the quotient. So I want to show you this with decimals for a second, just to show you what can be happening if we're experiencing this from third grade on up of using the area model for multiplication and division. Please know that when I first learned about this, my mind was screaming at me. My brain was saying, what are you talking about? And it's taken me, time to look at these and play with them and really visualize what's happening here. But what I can share with you for myself and my journey is that when I think of this as being, originally this has been a 100 for whole numbers. What if we say that the distance here, the distance is 1, and this distance here is 1, which means that this would be the area of 1, because a 1 by 1 would be 1 amount, right? So this is a distance of a whole. If I then brought down one of these, and you just think about the distance across here, right? 10 of these rods would make up this whole, which means that this distance is 1/10 of the whole, which is showing the area of a tenth, right? So if I think about this, I don't typically I find it very confusing with the rods. It becomes mind melding thinking about the area versus the distance of them. So what's helped me the most is thinking about, okay, this is going to be a distance. So this is going to be a distance of 1 whole, and then 3 more tenths. And then this is going to be a whole and 2 more tenths. So what this is a 1 and 3 tenths. And this distance here is a 1 and 2 tenths. And inside here, the area is 1 whole. The area is 3 tenths. The area is 2 tenths. And then the area here is a little more advanced, where it's 600ths, right? Because those little cubes in relation to this being a 1 whole, each of the area in here is 1/100th of that total. Now, I didn't just change these rods. This is the same example of the 12 times 13 being the 156. Now this is the total amount of 1 and 5600ths divided by 1 and 2 tenths. Do I have enough to make 1 and 2 tenths? Yeah, so this rectangle here measures 1 and 2 tenths by 1. Here, now that it gets a little more fuzzy, but I was able to build another 1 and 2 tenths and a 1 and 2 tenths in terms of the distance. But do you see how the area inside, though, is the 3600ths, right? That's where it does get a little bit wonky. But this is also going to be able to use again in polynomials way down the road. So that is division in a nutshell, and we'll go over this even some more during the week we focus on division. Have a great day, everyone.